The sound of muffled sobbing echoed through the abandoned warehouse district as 12-year-old Maya Johnson pressed her face against the grimy window of what had once been a thriving tech startup, watching a man in an expensive suit stand defeated before a massive whiteboard covered in complex mathematical equations and business projections that told the story of spectacular failure. Rashid Al Hakim had lost everything in the past 6 months. His revolutionary artificial intelligence company crumbling under the weight of fundamental flaws that his team of MIT graduates and Stanford PhDs had somehow missed, leaving him alone in the empty office space at 3 a.m., crying over calculations that no longer added up to the breakthrough that was supposed to change the world. What he didn't know was that the homeless girl watching through the window possessed a mathematical genius that had been ignored by every school system and social service that had encountered her, and that her young mind could see the elegant solution hidden within the chaos of numbers that had destroyed his dreams and consumed his fortune. Maya had been living on the streets for 8 months, since aging out of a foster care system that had never recognized her extraordinary intellectual abilities, dismissing her academic potential, because her behavioral problems and frequent moves between homes had created a school record that emphasized disruption rather than the brilliant flashes of insight that occurred whenever she encountered mathematical concepts that challenged her curiosity. At 12, she possessed an intuitive understanding of complex algorithms and statistical modeling that would have impressed university professors, but her circumstances had prevented anyone from discovering that beneath the appearance of another troubled foster child lay one of the most naturally gifted mathematical minds of her generation. The foster care system had failed Maya in ways that went far beyond simple neglect, because the social workers, teachers, and psychologists who encountered her during her childhood had been trained to see behavioral problems as indicators of limited potential rather than possible signs of intellectual giftedness that was being frustrated by inadequate educational opportunities and unstable living conditions. Her tendency to question authority, challenge incomplete explanations, and become bored with repetitive lessons had been interpreted as defiance, rather than evidence of a mind that needed more sophisticated challenges to remain engaged and productive. Maya's mathematical abilities had first become apparent when she was 7 years old and living with her third foster family, where she had corrected errors in her foster father's accounting software that professional bookkeepers had missed for months. But instead of recognizing her talent, the adults around her had assumed she was lying or cheating, rather than demonstrating genuine understanding of complex numerical relationships that exceeded what anyone expected from someone her age. The series of foster placements that followed had each ended when Maya's intellectual needs clashed with caregivers who were unprepared to nurture a child whose questions about mathematics, science, and social systems revealed gaps in their own knowledge and challenged their assumptions about what children from difficult backgrounds were capable of achieving when given proper support and encouragement. The warehouse where she had taken shelter for the night had been the headquarters of Hakim Industries, until creditors seized the building 3 weeks earlier. But Rashid still returned obsessively to stare at the whiteboard where he had mapped out the artificial intelligence architecture that was supposed to revolutionize healthcare diagnostics, but had instead revealed fundamental logical errors that made accurate predictions impossible. His Arab family had invested their petroleum fortune in his vision of using machine learning to save lives in underserved communities, but the algorithm that was meant to democratize medical expertise had failed spectacularly during clinical trials, producing false diagnoses that could have killed patients if the errors hadn't been caught by human doctors who still understood medicine better than his supposedly superior technology. The collapse of Rashid's company had been particularly devastating because it had represented more than just business failure. It had been the destruction of his family's hopes for using their wealth to create positive change in communities that had been systematically denied access to quality healthcare. His father and uncles had supported his vision not because they understood artificial intelligence, but because they believed that technology could address the medical disparities that affected Arab and Muslim communities around the world, and his failure had not only lost their money, but had damaged their faith in innovation as a tool for social justice. The mathematical foundations of Rashid's AI system had been built on assumptions about data correlation that seemed logical to computer scientists, but ignored crucial variables that Maya could identify instantly, because her survival on the streets had taught her to recognize patterns that others missed, understand cause and effect relationships that formal education often obscured, and see connections between seemingly unrelated factors that academic training sometimes made invisible through overspecialization and theoretical abstraction. Her homelessness had forced Maya to develop analytical skills that traditional education could not provide, because navigating unsafe environments required understanding how multiple variables interacted to create dangerous or safe situations, how small changes in behavior could trigger large changes in outcomes, and how surface appearances often masked underlying realities that determined whether survival strategies would succeed or fail. "I can fix it," Maya said quietly, her voice barely audible through the glass, as she watched Rashid erase another section of equations in frustration. But her words carried across the empty space with the confidence of someone who had already identified the core problem that had eluded teams of expensive experts. Rashid looked up from his calculations, initially thinking that exhaustion and stress were causing him to hallucinate voices. But when he turned toward the window, he saw a small face pressed against the glass, belonging to a girl whose clothes and appearance clearly marked her as homeless, but whose eyes held an intelligence that seemed incongruous with her circumstances. "Who's there?" Rashid called out, his voice carrying the wariness of someone who had learned that unexpected visitors usually brought more problems rather than solutions, especially in the dangerous neighborhood where his former office was located. "My name is Maya, and I've been watching you work on those equations," she replied, her tone carrying the matter-of-fact honesty that children use when they want to be helpful rather than intrusive. "I think I know why your algorithm isn't working right." The claim that a homeless child could understand artificial intelligence programming that had confounded his team of experts struck Rashid as either delusional or some kind of elaborate scam, but his desperation had reached levels where even impossible solutions seemed worth investigating, if they offered any hope of salvaging the work that had consumed 5 years of his life and destroyed his family's financial security. "How could you possibly understand what I'm working on?" Rashid asked, his tone carrying skepticism, but also curiosity, about how someone so young and apparently disadvantaged could even pretend to comprehend the complex mathematical relationships that governed machine learning algorithms. "I understand math and patterns," Maya replied simply, as if her extraordinary intellectual abilities were just another survival skill she had developed during her time on the streets. "And I can see that you're trying to make your computer think like a human doctor, but you're using the wrong kind of learning because you don't understand how real thinking actually works." The insight about the fundamental flaw in his approach was delivered with such casual confidence that Rashid found himself unlocking the building's front door and inviting Maya inside, driven by a combination of curiosity and the desperate hope that a fresh perspective might reveal solutions that had eluded conventional expertise. Maya entered the abandoned office space with the careful alertness of someone who had learned to assess new environments for potential dangers, but her attention immediately focused on the whiteboard, where Rashid had been struggling with equations that represented months of failed attempts to correct his algorithm's diagnostic errors. The whiteboard itself was a testament to Rashid's obsessive efforts to solve problems that had defeated his entire research team, covered with layer upon layer of calculations in different colored markers that represented various approaches to machine learning that had all proven inadequate for the complex task of medical diagnosis in real-world conditions where patients presented with multiple interacting symptoms and social factors that textbooks rarely addressed comprehensively. "You're trying to teach your computer to recognize diseases the same way a medical textbook does," Maya observed, studying the mathematical formulas with an intensity that revealed genuine understanding rather than mere curiosity. "But that's not how people actually figure out what's wrong when someone is sick." The observation about the difference between textbook knowledge and intuitive diagnosis struck Rashid as surprisingly sophisticated for someone who appeared to have no formal education in either medicine or computer science, and it suggested that Maya's understanding of his work might be more genuine than he had initially assumed. "How do you think people actually figure out medical problems?" Rashid asked, his tone shifting from skepticism to genuine interest as he recognized that Maya's perspective might offer insights that his academic training had overlooked. They look at everything together, not just one thing at a time, Maya explained, her voice carrying the confidence of someone who had observed human behavior with the analytical precision that survival often required. When I was little and got sick in foster homes, the good doctors didn't just ask about my fever or my cough. They asked about where I lived, and what I ate, and how the other kids were treating me and whether I was scared about something. The holistic approach to diagnosis that Maya described represented exactly the kind of contextual analysis that Rashid's algorithm had been designed to perform, but which had failed because his programming had isolated medical symptoms from the social and environmental factors that often determine their significance and meaning. Maya's experience with medical care in foster homes had taught her that the quality of diagnosis often depended less on the sophistication of testing equipment than on the doctor's willingness to understand the patient's complete life situation, including factors like housing stability, food security, family stress, and exposure to violence that significantly affected health outcomes, but were rarely captured in electronic medical records that artificial intelligence systems used for training data. Your computer is trying to be too smart about medical stuff and not smart enough about people stuff, Maya continued, her childlike language paradoxically containing insights that had eluded sophisticated analysis by experts who understood technology but had never experienced the kind of systemic neglect and institutional failure that shaped health outcomes in underserved communities. The distinction between medical knowledge and understanding of social determinants of health revealed a gap in Rashid's algorithm that no amount of clinical data could address because his artificial intelligence had been trained on symptoms and test results without comprehending the poverty, stress, environmental hazards, and lack of access to preventive care that created the conditions where diseases developed and flourished. "Show me what you mean," Rashid said, handing Maya a marker and stepping back from the whiteboard with the kind of desperate openness that comes from having exhausted all conventional solutions and being willing to consider advice from the most unlikely sources. Maya approached the whiteboard with the systematic thinking that had allowed her to navigate complex social service bureaucracies and survive in environments where understanding hidden patterns could mean the difference between safety and danger, but applied to mathematical relationships with an intuitive grasp that amazed Rashid with its sophistication and elegance. Her movements around the whiteboard were confident and purposeful, suggesting that she had been thinking about the problems represented in his equations long before speaking up, and that her analysis had already progressed far beyond simple observation to include specific solutions that addressed the fundamental flaws she had identified in his approach to machine learning. "This part here is where you're making the mistake," Maya said, pointing to a section of equations that represented the algorithm's decision tree for prioritizing diagnostic possibilities. "You're telling the computer that some symptoms are more important than others, but that's only true if you know everything about the person's life." The critique of his hierarchical symptom analysis revealed a fundamental flaw in Rashid's approach that had been invisible to his team because their medical training had taught them to prioritize certain indicators over others based on statistical probability rather than individual context, creating blind spots that Maya's street experience had taught her to recognize and avoid. For example, Maya continued, beginning to modify his equations with corrections that demonstrated mathematical understanding far beyond her apparent age and education. If someone has a headache and lives in a place with lead paint, that's different from a headache in someone who lives somewhere safe. But your computer doesn't know about the paint, so it makes the wrong guess about what's causing the problem. The insight about environmental factors affecting diagnostic accuracy highlighted the social justice implications of artificial intelligence that had been developed without input from communities that would be most affected by its deployment, and it forced Rashid to confront the limitations of technology that had been designed by privileged experts who had never experienced the conditions that their algorithms were supposed to address. As Maya worked on the whiteboard, her modifications to Rashid's equations revealed not just mathematical sophistication, but deep understanding of how poverty, racism, and social neglect created health disparities that required different analytical approaches than those used for patients with access to comprehensive health care and stable living conditions. Her corrections involved adding variables and weighting factors that his original algorithm had completely ignored, creating mathematical models that could account for social determinants of health, like housing quality, food security, exposure to violence, access to transportation, and family stability that significantly affected both disease development and treatment effectiveness, but were rarely included in medical AI systems. You need to teach your computer to ask different questions, depending on who it's trying to help, Maya explained, as she continued refining the algorithm with changes that addressed systematic biases in medical diagnosis that Rashid's team had never considered. Rich people and poor people get sick in different ways, and they need different kinds of help to get better. The recognition that diagnostic accuracy required understanding of social class, racial discrimination, and economic inequality represented a breakthrough in thinking about artificial intelligence that could transform not just Rashid's specific algorithm, but the entire field of medical technology development, because it acknowledged that technical solutions could not be separated from social context without creating systems that perpetuated rather than addressed existing disparities. Maya's approach to modifying the algorithm demonstrated understanding of machine learning principles that went far beyond what could be explained by casual observation, suggesting that she had been teaching herself advanced mathematics and computer science concepts through methods that formal education systems had never recognized or supported. Where did you learn about machine learning and artificial intelligence? Rashid asked, his curiosity about Maya's background growing as her expertise became increasingly apparent through the sophistication of her mathematical corrections. I taught myself by reading books and papers that people throw away, Maya replied matter-of-factly, as if self-directed learning at a graduate level was a normal response to being failed by conventional education systems. Libraries let you use computers even if you don't have a home address, and there are lots of free math and science courses online if you know where to look. The revelation that Maya had acquired advanced technical knowledge through resourcefulness and determination rather than formal instruction highlighted the barriers that prevented brilliant minds from contributing to innovation when they lacked access to traditional educational pathways, and it suggested that the technology industry was missing enormous amounts of talent by focusing recruitment efforts exclusively on elite institutions. Over the following hours, Maya's corrections to Rashid's algorithm revealed layers of complexity that his team had missed because their privileged backgrounds had shielded them from understanding how institutional discrimination and economic marginalization affected health outcomes in ways that purely medical analysis could not capture. Her analysis extended beyond simple diagnostic accuracy to include considerations of treatment accessibility, medication affordability, and follow-up care availability that determined whether accurate diagnosis would actually lead to improved health outcomes for patients who lacked the resources to implement traditional medical recommendations. The reason your computer makes wrong guesses is because it learned from examples of people who could afford to go to good doctors, Maya continued, her analysis revealing systematic problems with the datasets that had been used to train his artificial intelligence. But most people don't get to see good doctors, so your computer doesn't know how to help them. The insight about training data bias exposed fundamental problems with machine learning systems that had been developed using information from elite medical institutions while claiming to serve populations that had limited access to such facilities, creating algorithms that were optimized for patients whose experiences were vastly different from those who most needed technological assistance. Maya's solutions involved not just correcting mathematical errors, but reimagining the entire data collection and analysis process to include information sources that reflected the experiences of marginalized communities, creating more representative training data that could support artificial intelligence systems designed to serve everyone rather than just privileged populations. You also need to change how your computer learns from new information, Maya added, introducing concepts about adaptive algorithms that could adjust their diagnostic criteria based on local conditions and population characteristics, rather than applying universal standards that might not be appropriate for specific communities or geographic regions. The idea of contextually adaptive artificial intelligence represented a significant advancement over static systems that treated all patients identically, regardless of their circumstances. And it demonstrated Maya's understanding that effective technology needed to be flexible enough to account for the enormous diversity of human experience and social context. As dawn began to break through the warehouse windows, Maya's work on the whiteboard had transformed Rashid's failed algorithm into something entirely new. An artificial intelligence system that incorporated social determinants of health, environmental factors, and economic context into medical diagnosis, creating more accurate and equitable healthcare technology than anything his original team had imagined possible. The mathematical elegance of Maya's solutions impressed Rashid not just because they solved technical problems, but because they did so in ways that aligned with his original vision of democratizing healthcare through technology, creating systems that would actually serve the communities that most needed assistance, rather than simply generating profits for technology companies and elite medical institutions. How did you learn to think about these problems this way? Rashid asked, his voice carrying genuine admiration for intellectual abilities that had been hidden by circumstances that prevented society from recognizing Maya's extraordinary potential. When you live on the streets, you have to understand how everything connects to everything else, Maya replied matter-of-factly, as if her insights about complex systems thinking were just practical survival skills rather than revolutionary contributions to artificial intelligence development. If you don't see the patterns that other people miss, you don't survive very long. The explanation of how marginalization had created analytical abilities that privileged education could not provide forced Rashid to reconsider his assumptions about intelligence, expertise, and the sources of innovation that could address society's most challenging problems. I want to offer you a partnership, Rashid said, his entrepreneurial instincts recognizing that Maya's unique perspective and mathematical abilities could transform not just his current project, but his entire approach to technology development. What you've done here represents exactly the kind of breakthrough thinking that could revolutionize how artificial intelligence is used to help people. The offer of genuine collaboration rather than charity reflected Rashid's understanding that Maya's contributions were valuable in their own right, not just inspiring examples of overcoming adversity, and that her insights could benefit everyone, rather than simply serving as feel-good stories about individual resilience. I want to help, Maya replied, her voice carrying the excitement of someone whose intellectual abilities had finally been recognized and valued. But I need to make sure that whatever we build actually helps people like me, not just people who already have everything they need. The condition that their work should prioritize serving marginalized communities rather than generating profits for wealthy investors aligned with Rashid's original vision of democratizing healthcare through technology, and it provided the moral framework that his previous efforts had lacked because they had been developed without input from the communities they claimed to serve. We'll create an advisory board of people from the communities we want to serve, Rashid proposed, his mind already working on implementation strategies that would ensure their technology development remained accountable to the people who would be most affected by algorithmic decisions. And we'll make sure that ownership and profits are shared with the communities that contribute to our success. The commitment to community ownership and shared benefits represented a fundamental departure from traditional technology industry practices that extracted value from marginalized communities while concentrating profits among wealthy investors and elite technologists, creating a more equitable model for innovation that could serve as an example for other companies. Over the following months, Maya's collaboration with Rashid produced artificial intelligence systems that revolutionized medical diagnosis in underserved communities by incorporating social context, environmental factors, and economic realities into algorithmic decision-making, creating more accurate and culturally competent healthcare technology than had ever existed before. The success of their partnership attracted attention from major technology companies and medical institutions that wanted to license their innovations. But Maya and Rashid insisted that any licensing agreements include requirements for community benefit and algorithmic accountability that ensured their work would continue to serve marginalized populations rather than being co-opted for profit maximization. The homeless girl who had been dismissed by every institution that encountered her became one of the most influential voices in artificial intelligence development, speaking at conferences and advising technology companies about how to create systems that served everyone, rather than just privileged populations who had traditionally been the focus of innovation efforts. Rashid's company was rebuilt on principles that Maya had introduced, with hiring practices that prioritized diverse perspectives over traditional credentials, and with technology development processes that included input from communities that would be affected by algorithmic decisions, creating more equitable and effective artificial intelligence than had been possible when innovation was controlled entirely by elite institutions. Years later, when Maya received her PhD in mathematics and computer science through programs that Rashid had funded specifically for brilliant students whose circumstances had prevented them from accessing traditional educational opportunities, her dissertation on socially aware artificial intelligence became the foundation for industry standards that required algorithmic accountability and community input in technology development. Before we wrap this story up, I'd like to congratulate you for reaching this far. And if you enjoyed this story as much as I think you did, then be sure to check out the rest of our channel for more exciting and inspirational stories like this one. And don't forget to show your support by liking and subscribing, so this channel can reach more people just like you. Now, back to the story. The whiteboard where Rashid had been crying over his failures became a symbol of transformation, displayed in their company's headquarters, as a reminder that the most important innovations often came from recognizing wisdom in unexpected places, and that true intelligence required understanding, not just technical complexity, but human complexity in all its forms. The homeless girl who had offered to fix a broken algorithm had fixed far more than computer code. She had demonstrated that genius could emerge from any circumstances, that the most valuable perspectives often came from people who had been systematically excluded from opportunity, and that technology could only fulfill its promise of improving human life when it was developed by and for the full diversity of human experience, rather than just the privileged few who had traditionally controlled innovation, determined whose problems were worth solving.